if you're interested in making impacts, then you really should plan your research around things that someone has indicated is needed or they're interested in. And there are places you can go to find those areas. The biggest one that I should push for NHERI is a science plan. There is a science plan which is somewhat comprehensive in all of the various hazards. It probably doesn't get down to an individual project level, but it certainly covers all of the areas that we think NHERI should be focused on in order to improve our performance from natural hazard issues. So there are other places, however, you can go. This presentation, by the way, I happen to have in a can because San Diego EF asked me to give such a presentation. So I didn't do this in the last 5 minutes. I would like to be able to do such things, but I can't. But for the wind area, because theoretically NHERI has people interested in all of these hazards, there is something called the National Windstorm Impact Reduction Program. And I checked this link this morning and it still works. So there is a science plan kind of a thing from that group that lists things that they think they need. Similarly, in the tsunami area, there is a similar research plan that came from a workshop that was sponsored by NSF and NOAA, and I checked that link as well. And then lastly, in seismic, the Building Seismic Standards Committee is really the committee that produces new earthquake provisions. And at the end of their cycle, they produce something called Future Issues and Research Needs, which gives a long list of things which that committee thinks is needed in the seismic area to improve codes. So all of these places you can look, and if in fact you come up with a research project that fits into one of these things, someone should be interested in it. So more in the seismic area, the NHERI Provisions is a feeder to the Seismic Provisions of ASCE 7. It's funded by FEMA. It's the best place to get seismic research implemented into codes because their provisions go straight to ASCE 7 committee, seismic committee. They don't have to adopt virtually every change, but they usually adopt most of it. So at the end of the cycle, as I said, there's several documents. There's a provisions document, a commentary document, and then resource papers. And the resource papers document work that the committee has done, but it didn't really get into the code yet, either because it needs more work, that subject area needs more work, or for some reason it just didn't pass into the code. So those resource papers are one source of ideas you could get in a seismic area. And then, as I mentioned, there's this Future Issues and Future Needs document, which is available on the BSSE website that gets into great detail about what the committee felt was needed for the next 5 years. This just gives an example of the resource papers that are published as part of the NHERI provisions. I'm not going to read all of these, but there are areas in geotechnical, there's areas in steel and other materials, diaphragm design, for example. All of these areas the committee has worked on, but has not completed upgrades to the code. And then there's this, again, a Future Issues and Research Needs. I updated this link, so this link should work. This goes into great detail about what is needed in the seismic area. There's some highlights from that. Functional recovery, of course, is the big keyword now for all the hazards. So design criteria for that is of high interest. Design guidance for rocking structures. There's been a lot of research about rocking brace frames and rocking shear walls, but there's really no design guidance about how to design something using that. The vertical component of ground motions in earthquakes is getting more and more interest in terms of its importance. The duration of ground motions, we don't think that our current code deals with very, very long ground motions that we might expect in the Pacific Northwest right now. So there's a lot of people, especially in the Pacific Northwest, that are interested in trying to understand that problem. Non-structural components is always an issue. It's very difficult to get non-structural components properly installed. Cast in place concrete diaphragms, as I mentioned, we just don't have very much tests about diaphragms, although they're very important in our seismic systems. And then the interaction of non-structural finishes in a lateral system of wood frame structures. So those are just areas that you could go to these different documents and maybe come up with some ideas for research projects that in fact should have people that are interested. So the next issue is getting, when you're starting the research, getting involved with some committee member or some person that is in that particular code area to help you. So the other assistance for implementation besides planning is us, the Neurotechnology Transfer Committee. And this is the flyer that Robin has made available to you. It's just as sort of an advertisement that we exist and we're here to help the whole NHERI community with technology transfer. We have about 20 people that are on code committees or geotechnical people in all areas of the NHERI hazards. And of course, codes are not the only place to get technology transferred. For example, geotechnical people have not very many codes. So the geotechnical improvements, particularly in liquefaction and so on, prediction of liquefaction often goes right straight into industry. They pick up the research directly. So there's other policy areas that also don't need codes. So it's important to understand the whole wide range of people that would be interested in the research. So the flyer is there. There's also a paper we have produced called Mechanisms for Implementation of NHERI Research Results. It goes. Well, there is a place on that flyer where theoretically you can request a consultation with us, and it works. I've had an inquiry or two. So if you would like an hour conversation with somebody on the Technology Transfer Committee, you can email that line there. So the white paper I talked about is also available on Design Safe. It includes common methods for implementing research results, including codes, FEMA, NIST, other areas, local policy people, geotechnical people, so on. And it also includes steps to make research more readily implementable in updating codes and standards. And there is an issue with NSF research that often researchers finish and there's always another step to some kind of simplify or clean up the research results in a situation that would go into codes, and NSF does not fund that. So there is some frustration among researchers that they get their research done, but they run out of funding. So you really need to get someone in the codes and standards or someone else that's going to implement your research and get them involved early in your research so that they would be able to take this step. There's also in this white paper an overview of existing building codes and standards, such as all of the committees of ASC 7, which includes all the hazards that we deal with. And then there's ASC 41, which is another standard for seismic retrofit of existing buildings. There isn't similar and parallel documents for retrofit for wind or tsunami. There's also an overview of research implementation and tech transfer programs. Federal organizations such as FEMA, NIST, ATC, and BSCC all are involved in, sometimes, not always, in taking research and putting it in a more implementable form. There's also information on privately funded entities and tech transfer activities conducted by other early adopters. So we also thought about methods of implementation when proprietary materials and design and construction methods are involved. Sometimes research invents something, some kind of a widget or some kind of a methodology that is new, but it's proprietary. That implementation is different because it doesn't really go into codes, because the code doesn't deal with proprietary systems, but there are other ways of implementing that kind of research results. So also it encourages presentations at professional associations, cross-disciplinary meetings and webinars of your research, so that the best way to get technology transferred is to make people aware of it. So you have to announce broadly what you're doing and get people interested. This book also stresses the importance of industry involvement during the research. Many research projects have review boards or consultants, which are local engineers or other implementers that would be interested in your research, and you get them involved right from the get-go and ask their guidance on maybe focusing your research in a way that would be more useful to them. So this is a link to that white paper. As Robin says, I think it's also on the Technology Transfer website. So thank you for this time. She sent me some questions that your other speaker was going to try to deal with. It seemed like it's more on the impact side. One of them was, what data and technology resources exist? How can we use them to impact practice? I'm not sure what that means, although it turns out, for those of you who know and use DesignSafe, it turns out the results of NHERI research, and before that, NEIS research, which was an earthquake program, is all archived on DesignSafe. And it's archived in a way, the idea was that a different researcher could use the results of experiments to come up with some different answer, to come up with a new result that wasn't thought of by the original researcher. That's not my wheelhouse because I'm not really a researcher, but the fact of the matter is all these data bases exist, and I'm sure your professors in your area could help you figure out what exactly there, and is there something there you could use. How long does it, interesting, how long does it take a research topic output to be actually adopted in practice? This is kind of a downer, really, because if you're talking about codes and standards, it really takes like 7 to 10 years, and that's hard to believe. But by the time it goes through, it gets out of your research, it then goes through some kind of a transformation to be more usable. Then it goes through all the code committees, usually of which have cycles of 3 to 5 years. Then it goes from that development group into a code committee, which might take another 3 to 5 years. And then when it actually gets put into ASC 7 or the IEBC or someplace, it then takes another couple of years for that code organization to adopt it. So it's a very long time if you're talking about codes. If you're talking about geotechnical improvements, as I point out, geotechnical engineers will pick up improvements that they can use in their work almost immediately. So if you are working in a geotechnical area, I would encourage you to get some geotechnical people that are knowledgeable in your area involved in your research, and they could help guide you to better to produce something that they can use more quickly. The tough one is, what are some ways to communicate science effectively? That's not my thing. That's a communication issue, so I'll pass on that. But I'd be happy to answer any questions if we have any time left.
We do. Do you mind if you'll stop sharing, and then we can see everyone as they are speaking? Okay. Thanks so much, Bill. Thank you so much. Does anyone have questions for Bill about technology transfer or impact of research on practice and what that might look like? You can put it in the chat or you can unmute and simply ask.
Maybe I just answered all the questions.
Those were the main ones they came up with last time. So I appreciate you. I learned a lot because obviously this is not my area.
I have a question.
Okay.
Yes.
So with regards to the codes that you mentioned that, it takes close to 10 years to actually standardize them and bring them into practice. I mean, with the fast-paced advancement in technology and research as it is, even I know that in research takes, we're doing like something like 5 years ahead of its time that's there in the industry, the stuff that we do. So how can the standards keep up with that? Because it's going to get outdated pretty soon. Because even in civil engineering, when I was in the industry, like for a bit, I've seen that, it's pretty much standards there are formulated in the 90s and it's still being used in practice. And the things that we do now is way far more advanced and it's more research. How can that keep up with that? What can we do with that?
I think it depends on the nature of the result or the research. If it is really something that has been proven to be a safety hazard in the way we do things, it would go a lot faster than that 10 years. If it's just a general improvement in some design or some new result for shear walls or something, then it might go through that whole 10-year period. But for example, in the Northridge earthquake, there was a problem with steel frame buildings, which nobody realized. Nobody meaning the steel industry, the structural engineering industry. And it was pretty scary because there are a lot of steel frame buildings in earthquake country. As a matter of fact, before that earthquake, everyone said the steel frame building is the best earthquake resistant building that we have. So it turns out that that earthquake was in 79, and FEMA funded a massive study which involved 3 different organizations. And by the 84 UBC, changes were made. So that was kind of a crisis situation. And that happened in 5 years. I mean, it actually went into the code in 5 years. So I think if it's most code changes as a result from research are not so dramatic. They're improvements, but they're not something that's changing a life safety hazard or eliminating a life safety hazard. So, but unfortunately, other than that, that's just the process we have. It is frustrating, but it takes a long time.
Thank you, Bill. Any other questions?
Yeah, I might have one. So as researchers, how can we contribute actively for the technology transfer as students?
Well, as students, not altogether clear, but when you start doing research, as I pointed out, as I said, some people are not interested. They just want to solve problems. But if you're really interested in getting something, the technology into practice, you need to do research that somebody has said, we need this. We need an improvement in tsunami, some aspect of tsunami. So then you try to do research that answers that question because there's someone in the industry has asked that question. So therefore, we know there's a demand. So if your research is answering a demand, that's one way to quickly get it in practice. And then while you're doing the research, get knowledgeable people involved to help you focus to solve the problem that was identified somewhere in a workshop that you're trying to solve. So I think those kind of activities would help speed up the technology transfer.
Okay, thank you.
Thank you, Bill. Any other questions? Okay, and I'm gonna put another link in the chat. The NHERI Science Plan actually runs through a whole bunch of different hazard examples and areas that we really need solutions for. They're problem areas, and they walk you through those different problems. So if you are researching earthquake, wind, tsunami, coastal engineering, simulation, and modeling of any of those, as well as there is a little bit of social science into. They're coming out with a NHERI Science Plan 3 that will be integrated with social science. They have, it's just a great place to start to find out what are some major problems that are out there that I can help solve. They don't tell you exactly individually what every single problem is, but it puts you in specific areas and helps you understand where you might concentrate. So that's a resource that you might consider looking at as well, because as Bill pointed out, if you know the problems that are out there, solving them then puts you towards on the path to be able to impact practice through your research. So any other questions for Bill?
Hi, Bill, this is Holly. I'd just like to thank you for spending time walking us so clearly through the process of how to have research that can make an impact. Just thank you for helping to bring up the next generation behind you.
You're welcome. And I'd like to put a pitch into your student council that I would like the Technology Transfer Committee to appear once a year before a group. That would be great.
I think that's something that we can make happen for sure. Bill, is it all right? Do you mind sharing your slideshow with me so I can pass it on to all the students so they have all those links?
Sure. I'll send it to you.
Okay, then I'll make sure that everyone gets that in an email later on today. Bill, thank you so much. Again, I appreciate it.
Okay,
And I
thank you.
enjoyed it. Thank you.
Okay.
Have
I'll
a great
send you the
day.
link.
Yes, thank you.